Hi everyone, it's Coach Red here, and today I'm going to be talking about, or giving an introduction to trigonometry. And so we're going to be talking about something called a trigonometric ratio. These ratios, the names that we call them are sine, cosine, and tangent. But in order to do that, I want to make sure that we recognize a couple things about a triangle. Now these ratios are used in right triangles, so as a warm-up, let's look at this triangle here and let's everybody mark their angle C as the right angle, okay? And so when we talk about a right triangle, it's important to know that these two sides are the legs and AB is the hypotenuse, the longest side in the triangle. Now, although angle A and B look like they might be congruent, they're not. We don't know that. But in trigonometry, everything we do is going to relate to an angle in the triangle and the legs or hypotenuse. So we sometimes will say, okay, what's the leg opposite to A? So opposite to A would mean across from A, so segment CB is opposite to angle A. Adjacent to angle A, when we're talking about that, we're talking about the legs that are adjacent, okay? We're not ever talking about the hypotenuse. We'll call it the hypotenuse. So a leg adjacent to A would be, adjacent means next to, so segment AC. All right, let's look at angle B. If I'm talking about angle B and I say what is the opposite leg to angle B, that would be, so opposite to B would be AC, so leg AC. And then adjacent to B would be CB. Okay, it's important to know also that in a right triangle, angle A and angle B are complementary. Okay, so let me say that again. It's a vocabulary word from earlier this year. Angle A and angle B are complementary. Complementary angles are angles that add to 90 degrees. Well, that should kind of make sense to you. If this is a 90-degree angle and the three angles of a triangle add to 180, well, 90 plus 90 is 180. So these two together, angle A plus angle B, would have to equal 90, which means they're complementary. All right, well, let's talk more about trig. Trigonometry really comes from two Greek words, trigonon and metron. And trigonon, I want you to think about triangles, right? And metron means measurement. And so that's really what we're going to be doing. We're going to be measuring triangles, but lots of different measures. The side lengths have measures, they have a length, and then the angles have measures. And trigonometry allows us with right triangles to not only find missing sides, but also to find missing angles. So let me remind you of those three words, those three ratios I mentioned earlier: sine, cosine, and tangent. So much of this unit is going to be focused on these three ratios. All right, let's look where they come from first, okay? So here I have a set of several triangles, and they seem to be overlapping. I want you to just pause a second, take a second, and ask yourself, what do you notice? What do you wonder about the, I'm going to say, three triangles presented here? Again, they're overlapping, and I'm going to put in a right angle here, here, and here. Give you a second. I would like you to write three things down. Press pause and do that. Okay, so you're back, and you might have said, gosh, I noticed that they all have angle A in them. Triangle ABC, triangle ADE, triangle ADE, and triangle AFG. You might have said, I wonder if they're similar, because we know that we've spent a lot of time on these overlapping triangles and they were similar. Well, if they all have right angles in them and they all have a 31-degree angle in them, the angles are congruent, so they would be similar. You might have said, I noticed 3, 6, and 9 are multiples. You might have said, oh gosh, this is 5, and this is 5. I wonder if the whole thing is 15. You might have said, I wonder if AE is 10. you might have wondered or noticed that you might be able to find this angle in each of the triangles. Those are all the things that I'm hoping that you noticed that you could probably do without even any direction from me, okay? I'm going to ask you now to go ahead and use the triangle and find the ratio that I'm asking for here in lowest terms. So press pause and go ahead and do that. All right, so I'm hoping that you got your ratios, and you might have noticed that the first one was 3/5, the second one was 6/10, and a third one was 9/15. Now, it's important to notice that if you simplified the second two, you would get 3/5, and you would get 9/15, because these are similar triangles, and so that means that the side lengths are in proportion. Well, what that might mean for you, if you really thought about what you noticed and wondered, those side lengths actually play a role in the angle that's created in this triangle. Actually, both the acute angles in these triangles. And that's where trigonometry comes in. Those ratios help us find those angles that are the acute angles in a triangle. And so basically, engineers and scientists have found it really convenient to formalize these relationships by naming the ratio of the sides, okay? And so they can be summarized. So here we go. Here we go. They're summarized as sine, cosine, and tangent. All right, first of all, if we have a right triangle, so let's mark C as congruent, we want to place side lengths A, B, and C. Notice they're lowercase, across from the uppercase letter that's associated with it. So angle A, the side length opposite, we're going to put a lowercase a. Opposite B, a lowercase b, and opposite C, a lowercase c. All right, so the ratios that work out is that the sine of B is the opposite leg over the hypotenuse. So write that down. So in this case, B over C. The cosine of B is the adjacent leg over the hypotenuse. So I spelled that wrong, sorry. Over the hypotenuse. And the tangent of B is the opposite leg over the adjacent leg. And there's actually this funny mnemonic that I even learned it in high school. And I don't know who came up with it, but it just helps us to remember the ratio for sine, cosine, and tangent. And that mnemonic is SOHCAHTOA. 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 Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. So that can help us remember these ratios, because we do have to remember them for everything that we do with trigonometry. All right, guys, so that's just a quick introduction to trigonometry, and we're going to be spending some time learning how we can use all this information in our next lesson. Have a great day.